Picture this. It's 2009, and a highly sophisticated group of hackers quietly walks through the virtual front doors of the world's most powerful tech companies. But they weren't there for a quick smash and grab. They were there to move in. This is the story of Operation Aurora, a cyber attack so pivotal it literally wrote the playbook for modern nation-state espionage. We're going to break down how they did it, what they were really after, and most importantly, what you can do about it today. I mean, the sheer scale of this operation was just breathtaking. We're not talking about one or two companies. We're talking about more than 34 titans of industry. You know, companies like Google, Adobe, Symantec, even major defense contractors. The absolute backbone of Western technology and defense, all compromised at the same time. And maybe the most staggering part of it all? The stealth. For 6 full months, the attackers had the run of the place inside these networks. 6 months. They were moving around, grabbing credentials, finding their targets, all without setting off a single alarm. They were, for all intents and purposes, ghosts in the machine. So you have to understand, this wasn't just some random act of digital vandalism. No. As one analyst perfectly put it, this was a meticulously planned campaign. The goal wasn't just to cause chaos, it was theft. Industrial-scale theft targeting the single most valuable thing these companies owned, their intellectual property. Okay, so that's the what. But the big question is, how? How on earth did they get past the defenses of dozens of the most sophisticated companies on the planet? Well, the answer lies in a step-by-step attack, what we call a kill chain. And it all started by exploiting one single, previously unknown flaw. Let's break it down. The key that unlocked all of those doors was a 0-day vulnerability in, and you're not going to believe this, Internet Explorer. Yep, that Internet Explorer. It's a specific type of bug called a use after free. Now, I know that sounds super technical, but stick with me because the concept is actually pretty simple if you think about it like a hotel keycard. All right, so first, a program uses a chunk of your computer's memory to do its job. When it's done, it tells the system, hey, I'm finished with this spot, and that memory is now free. In our hotel analogy, this is simple. A guest checks out of their room, the room is now empty and available for the next guest. But here's the glitch. Here's where the mistake happens. The program keeps a reference, a pointer, to that now empty memory space. This is exactly like the front desk forgetting to deactivate the old key card after a guest checks out. That key still exists, and it still points to that one specific room. And this is where it all goes wrong. The system assigns that same memory space, that same hotel room, to a new process. In this case, the attacker's malicious code. The attacker then uses that old, forgotten key to just walk right in. And just like that, they have complete control of the room. A tiny little oversight leads to a total system compromise. So with that exploit as their key, the attackers ran their playbook with just chilling precision. It all started with a simple, targeted instant message. An employee clicks a link, and boom, the Internet Explorer 0-day gets triggered. It silently installs a backdoor called Hijack, giving the attackers remote control. From that one machine, they moved across the network, hunting for their ultimate prize, access to the company's version control system. Once they were in there, it was game over. They could just start pulling out the source code, the company's digital DNA. And that really gets to the heart of this entire operation. This wasn't just about embarrassing a company or stealing some user data. This was a heist, and they were after the most valuable assets you could possibly imagine. I mean, why go to all this trouble? Why execute such a patient, sophisticated, and incredibly risky campaign against dozens of really tough targets all at once? What on earth could be worth all of that effort? The answer is both simple and chilling. It was all about one thing: stealing their source code, the digital blueprints for the software and hardware that basically power our entire world. The very DNA of these tech giants was the prize. So why is source code the ultimate prize? Well, think of it as the master key to the kingdom. With the source code, an adversary can hunt for brand new, undiscovered vulnerabilities that no one else knows exist. They can literally clone competitor products, stealing billions in R&D. They can even secretly embed their own backdoors into the code, setting up future supply chain attacks. And in Google's case, they were also looking for insight into government surveillance systems, a massive counterintelligence win. Operation Aurora was a massive wake-up call, and its lessons are, frankly, more relevant today than ever before. So let's build a modern defensive playbook. We'll look at the specific gaps Aurora exploited and the controls we can use now to slam those doors shut for good. This table really lays it all out, doesn't it? The then versus the now. Aurora exploited an old Internet Explorer with no sandboxing. Today, we have auto-updating browsers like Chrome that basically trap an exploit in a secure box so it can't escape. They moved around undetected on endpoints. Today, we have endpoint detection and response, or EDR, that looks for suspicious behavior, not just known malware. They roamed freely across flat networks. Now, we can segment those networks with a zero-trust architecture, stopping that lateral movement cold. For every gap they used, there's a modern control designed specifically to stop it. So let's boil this all down to 5 critical defenses every team should have in place. First, harden your browsers and endpoints. That's your front line. Second, segment your network with a zero-trust mindset. Assume a breach is going to happen and limit the blast radius. Third, enforce phish-resistant MFA, like FIDO2 hardware keys, that can't be tricked by an email. Fourth, inspect your outgoing traffic, even when it's encrypted, to catch data trying to walk out the door. And finally, and this is so critical, you have to actively monitor who is accessing your source code repositories. Your code is a crown jewel. You have to protect it that way. Operation Aurora proved that for a determined nation-state attacker, your source code is the ultimate target. They are still out there, and their playbooks have only gotten more sophisticated. So that leaves us with one final urgent question you need to ask your team. Is your source code protected like the crown jewel it is?